Hello students, today we will discuss about JEE Mains 2015 physics paper. Now we will discuss all the questions one by one. Okay, let us start. Hello students, let us move to the question number 9. Here the question is, consider a spherical cell of radius r. So there is a spherical cell. Spherical cell is a hollow sphere. So it is a hollow sphere. Of radius r and at temperature T, temperature is T, the blackbody radiation inside it can be considered as an ideal gas. So the blackbody radiation inside it can be considered as ideal gas of photons. Okay, with internal energy per unit volume, that is given internal energy divided by volume is proportional to T4. So it should be T raised to 4. There is a mistake over here. It should be T raised to 4. Okay, there is a mistake. So it should be T raised to 4, and the pressure is P equals to 1/3 U by V. If the cell now undergoes an adiabatic expansion, it undergoes adiabatic expansion. The relation between T and R. So this is basically question about how to use the gas equation and then adiabatic expansion of T and V. Then for adiabatic expansion, or compression, we have the relation PV raised to gamma is constant. This is the equation we are going to use. Now the relation is not about P, this is about E, T and R. Okay, so I will write TV raised to gamma minus 1 is constant. This is also an equation that is used for adiabatic expansion. So I'll use this because I want the relation with T and R, T and R. So for T and R, I'll write V in terms of R. That's our aim. Our aim is to write V in terms of R. If I'm writing V in terms of R, then I'll have the relation between T and R. Then I'll see the options. So now from TV raised to gamma, this is equation number 1. Then think of this volume, and then we know that in PV equals to nRT equation, that this is your R, this is number of moles, this is pressure, this is volume, this is T. Now you can see here that the pressure is 1/3 U by V. Okay, and then the U by V is proportional to T raised to 4. So this U by V here, U by V here is proportional to T raised to 4. The P is also proportional to T raised to 4. P proportional to U by V, U by V proportional to T raised to 4. So P proportional to T raised to 4. So one equation I got that from question P proportional to T raised to 4. Okay. Now if I get P proportional to T raised to 4, so here, and the volume of a sphere is inside the sphere we have gas, and the volume of the gas is equal to volume of the sphere. The volume is proportional to R raised to Q, and P V equals to constant, and that P V is proportional to T. PV is proportional to T, and this R and this R, you should not confuse. This is the radius of sphere, and this R is the gas constant. Okay, the volume is proportional to q of the radius, but this is gas constant, so PV is proportional to T. Okay, but P is proportional to T raised to 4. So here, if I write V is proportional to T by P, then I write T by P is proportional to T raised to 4. T raised to 4. So this is 1 by TQ. So P is proportional to 1 by TQ, but then V is proportional to RQ. So RQ is proportional to 1 by TQ. From this, R is inversely proportional to T. This implies that from here, T is inversely proportional to R. If I see this, then I will have the option T is inversely proportional to R over here. So T inversely proportional to R is here, and also T is inversely proportional to R here. You can see this is the answer to this question. Okay, thank you.